Yeah, next week is the last week before break, right?
Yeah.
Very quick. Midterm exam.
A midterm exam will be in break.
In what?
Midterm exam.
Yeah, in the break.
Nice to see you, Sunday.
Yeah.
Hey, Jacob.
Sure. Oh, this here. Okay, I'm going to begin this new homework. And I know your, I mean, attendance good, but I just do this as a record.
Yeah.
Should we just rework the homework problems? Because I don't really.
Shall we get together and work it out?
I guess. I mean, do we just do all the homework problems?
I only submitted one due, so we can help.
Yeah. Yeah, no, because I don't really know how to study for it apart from just.
Yeah, I know it.
Yeah.
But the thing is, I just have so it's good if we can do it together.
Yeah, it's just so much.
I mean, I'm free the whole day tomorrow, even Thursday.
Yeah. Yeah, you can come to the PLC room after 2.
Yeah, Thursday.
Thursday.
Let's finish the note.
Did everyone vote in the SGA election?
Yeah.
No.
Did you vote? Well, no, I won't ask if you voted.
I voted.
What did you?
And Jen.
I
have
found your name and Jen's in a separate box.
Yeah.
Separate box for different categories.
Till when is
Yeah.
it
So
open?
I can vote too.
Yeah.
Kyle,
I
why would
voted.
I not vote for you?
Okay.
I don't know anyone else on there except for you.
That's true. The only thing is, I'm going to be a little bitter if I lose because the only other person running against me didn't come to the meeting where like they announced the candidates and everything. So like they didn't show up at all. I'm like, if I lose to the person that didn't show up, that's going to suck.
What should be the?
But-
Did you see that?
You got the email.
No.
SGA like.
Different Jacob.
Okay, good.
He's actually the director of finance
Alright, good.
currently, and he's not running again, but they put him on the ballot. And they put Zane on the ballot.
We voted for a
He will be
good
here.
candidate.
We need more physics.
Okay.
Thank you.
Homework, yeah. There's a shape, electric. Can you also, it's shape, right?
Initially,
Oh, yeah, still,
I was shocked by just one homework.
So basically, this is due right before the midterm.
yes. So, before midterm,
If you could not finish in a time, you can submit you can do in a break.
yeah. If you think you're fine, I don't need the help you to grade it.
We have to.
And, I mean, that's
we have to submit midterm.
together with midterm exam.
Yeah, I think the midterm will be enough to worry about over the break. So,
Yeah, this is the homework for chapter 7. Then, so Zane will be
you
here.
need to have you already signed it?
No.
Sorry.
No problem.
Are you freaking? What's your PA duties?
Wednesday from 9 to 11 and after 1 to 3.
That's when you do your 2
Yeah.
hours. Well, that's good.
After,
Where your friends
yeah, after 1. From 11.
I got free Tuesday. I got free Tuesday. Tuesday.
Tuesday.
Tuesday and Thursday.
Okay.
So what?
Oh, you just work again.
Yeah.
Tuesday too?
For fun. Not for any particular.
I think this example we discussed last time. Suppose we have 2 spin, and in this case we assume spin S is half and S2 is also half, right? In this case, we first discuss allowed eigenvalues for a total S. S is S1 plus S2, which is 1, and S1 minus S2 is 0, so there are 2 values. For x equal to 0, we have only m value 0, so we have only one state, the single state, right? Single. Then for s equal to 1, we know m has 3 values, so we have 3 states. Then we calculate the CT coefficient, multiply with spin time to get this square root 1 or square root 2, right? So 0, 0, and 1, 0. These 2 are limit, so we know that positive 1. Now we apply this result to consider the other issue. I think that's not in the last class. I'll just take the question here. How about this product S1, S2 apply to the states, in these states, one of states, but you can do any others. We just do one example. So question asks how much, right? Second question, S1 minus, right, or plus, and S2 minus apply the states, how much it is. So how to do this? And let's first work on this. So S1, S2. We know this is the joint eigenstates for this one. Joint eigenstates is S square, S1 square, S2 square, and S square. That corresponds to S and S M. This. So now we know this product of S1, S2 is, or this again joint eigenspace is not this product this, but we can rewrite this one in terms of the combination of this. Then we can apply, use this joint eigenstates behavior, right? So the first things what we have is the first answer this question, right? First, S1 we just rewrite. This is a sum of the technique we can. Later, if you make some like this, we can apply. So we know that is half of total S squared minus S1 squared minus S2 squared, right? And this are the joint, commute each other, so that is joint eigenstates. So very easily, so we rewrite this by half of S squared minus S1 squared minus S2 squared apply this. Then very easily we know S squared, this is joint eigenstates to S squared, so we know the eigenvalues, right? It's here. And S1 squared, S2 squared. So we immediately got this, for this is a square of the eigenvalue, so that is H bar squared S plus 1. That is S squared, apply this one, right? And then the second term is H bar squared S1 plus 1. Third one is H bar squared S2 plus 1. We use each one apply this. Then I take h bar square outside. So now we can prove the inside. How about the s value in this case? How much? This is s value, right? S, right? This one, right? S and M. So S, in this S is 1. So here it's 1 plus 1, and minus S1, half, right? Half plus 1, and S2 also half. Then the remaining I just add those numbers. So this is 304, so add together is 302. Wait. 304 multiplied, yeah, 302. And then this is a 2, right? So then the remaining is half, right? Because this is 2 minus 302 is half. So that finally, yeah, this is 304, yeah. 304 plus 304, that is 306, 2, that is 2. This is quarter 4, right? Not quarter 2. Right? 2. Yeah. Right? Okay, so that is the first one. Second one will be challenge. So now I'm going to answer this one. 1 plus 2 minus. Because this state is neither the eigenstates of 1 plus or, I mean, it is not easily to direct to that, right? So first, we are going to analyze this one. This is Sm, so we have this, let me use general, and then give you y into this, right? So that is m1s, m2s. We expand the states in terms of the product or linear combination of, since we have S1, S2, S, M1S, M2S, M, and S1, S2, M1S, and 2S, right? That is, and then this is the first thing. Second, whatever is, the I may be equal to 1 or 2, plus minus, apply the SI, MIS. We know this, right? That H bar, square root, SI minus plus MI. If I do small, S, SI minus, plus minus MIS plus 1, right? And SI and IS plus minus 1. This is the chapter 5, right? For I, either 1 or 2. That is for this case. And number 3. So S1, S2, M1S, and 2S, since they commute each other, so it is product of S1, M1S, S2, M2S. So we use those information. That makes sense? Then we can do. So after that, now let's solve first. This S equal to 1, M equal to 0, right? So here is this term. So first, this one is square root, 1 over square root 2, half this S1, S2, and M1S, M2S, plus half, minus half. That is equal to, I just write this, so we have 2 terms. And then S1 plus S2 minus, apply this. I'm going to, so we have 2 terms. Apply 2 terms. Now we have square root. I'm going to take the square root outside we got constant, then S1 minus, okay, now here, okay, let me write again second step, so I get this. Now here, I'm going to plus S1 plus S2 minus half minus half. Right, we have to apply these two states. Then the first one, minus 2. First one, since S1 minus only apply to S1 and S1, right? So that is S1 minus half, and then S2 plus minus is half minus half. So from this step to this step, I use this relationship. Because this state is product this, and S1 plus only apply to S1 M1X, right? So for this case, this is S1, right? S1, S2, M1S, M2S. This is the S1, S2, M1S, M2S. You have your homework. This is yours, right? Yes, new homework.
Awesome. Thank you.
Awesome.
Hey,
Okay.
it's better that we have it before the midterm, right?
That's good. Yeah, that's what I saw. So next Wednesday, right? You record it. Yeah. All right. So that is first term. From here to here, you just apply because this is only for first spin. So it only act on the states for S1, MS1. So that is S1, MS1 is plus, and S2, MS2, M2S. Yeah, M2S is this one, right? So that in the second one, S1 plus here, and M1S minus half, right? S2 minus half. Then we use this one. For each one, we know is this, right? So we have two products, right? So, okay. Now I'm going to ask you, when this S1 plus apply these states, how much? This already maximum value, right? So you cannot reach. Or you come to here for M1S plus 1, that is half plus 1, then here is minus, so half minus half is 0, right? So that is 0, this term. How about this one? Same thing, this is a minimum. So also a 0, right? So next one. So that first term actually 0 multiplied 0. Now let's go to second one. Second one, yes, this is a plus, means increase by 1 unit, so that is half, right? Yes. So now we use this h bar square root half. Now this one, right? Lowercase plus half. Sorry. This is raising now. Minus half. Right? Here is a raising. This one's a raising, right? So this is plus, so minus here, right? But M1S is minus, right? It's a negative, is negative. So that is minus negative, so that is plus. And then here, half, then plus is minus half, plus 1. Then the state is half, and then minus became plus, right? And the second term, h bar. Here is a minus, so I took the lower part, right? So that is half plus, this is a half plus, right? This is a half minus half plus 1. And then here half, so this is a minus, so from plus became negative. All right, so this one is speak carefully. So now here, this is a 1, right? Half cancel. So this is also 1. Half plus half, so that is 1. And let's look at this. This is a 1, this is also 1. So that is, we have h bar square root 2 is here, right? This term. And state is half. Okay. M1S plus, right? So that is M1S half. And M2S become negative. All right. That is how we use our knowledge to deal with this type of problem. And just give you an example. Later, if whenever you meet that kind of question, you can think about how to dealing with this. So we do one example about this addition of two angular momenta. This is one example. Now we do one more example, which is coupling of orbital and spin angular momenta. That is very common. For example, in the hydrogen atom, we have an electron, right? It's proton here. Then we have an electron here. Suppose let's do the circle with the L orbital and then have a spin. So this total angular momentum, and the momentum is addition of these two, right? That characterizes the whole picture or property of the electron move around the nucleus. So that is the coupling of orbital and spin and let's discard this. So the total angular momentum G is L plus S. Like G1 is L and G2 is S. So we consider this case. All right. This is a kind of application, right? Addition of angular momentum. So for this now first consider the allowed eigenvalues, right? I think we already know this. So here, J square, L square, S square, and JZ. They commute each other, so they have a joint eigenstates is Jm, right? That is, so now we need to find what is G allowed value G and allowed value M. So that is eigenvalues of G and M. For when given G1, G2 is given L and S, right? L is the quantum number of the orbital angular momentum, and S is a quantum number of spin. So now for giving L and S, how the allowed value for, this is the first question, right? Allowed value for G and M. Now we know G is between the G max, that is general, right, and G minimum. So in this case, G max is L plus S. So that is all the numbers. But the radius equal to L minus S, right? That is the allowed G value. Now, S, so first, because L equal to what? Angular momentum chapter 5, right? 0, 1, 2, 3, all the integer numbers. And how about S? Only half. That is fixed, right, for spin, for electron. So, then the G value, G is smaller and equal to L plus half, right? And the large or equal to, I use absolute value because if L equal to 0, that is negative, so we have to still take this. So that is allowed G value for given L, because S already given. So L depends on which value, right? So that means for given L, you have this value between the G value between this. Now, so now G actually equal to how much? 0. Half. Only half in this case if L equal to 0, right? So when L equal to 0, the G value only one value, which is spin, and that makes sense. In that case, angular momentum is 0. So the total angular momentum is spin. That is half. And the remaining part is, there are two cases, right? Okay, L plus minus half. So if L not equal to 0, right? between, for given L, L plus half and L minus half, right? So that is. Okay, so now this is giving the eigenvalue. Then next step is how about the joint eigenstates, right? So we are going to find how much joint eigenstates and then how to express the joint eigenstates in terms of the eigenstates of optimal momentum and state. So now second one, joint eigenstates. That is Jm, right? Jm depend on the L is L plus half or L minus half. So L plus half, this group for this, and then L minus half. Okay. Right. So because L has two values, either plus half is maximum value and the minimum value is minus half. And how many states, how many m value? Yeah, G and G, right? Because this. So for this case, that is the states number of states is 2m plus 2j. Is 2j plus 1, right? Then in this case, you will see for j equal to L plus 2, then that is 2L plus half, L plus half multiplied 1 is equal to 2L plus 2, right? States. Second one is L minus half plus 1. So that is 2L minus just 2L. That is depend on the m. For given L, how much allowed m value. So once we have this, now we have two groups, right? One is the group of states for this, another this. Then we are going to find the CG coefficient because here, for any joint eigenstate, must be some of for m. Now I'm going. Now m1, m2. Now I'm going to give index ml is m1, and m2 is ms. So ml plus ms equal to m, right? That is a select row. C, L, S, J, M, L, M, S, M, and then here L, S. S is half, right? So we can just use the general. Then we are going to discuss each individual. That is for any joint eigenstate we can expand in terms of this product of each individual angular momentum, remember, and the Scotting coefficient. So the key is we're going to find this, right? Once we know this, so we can express this, right, in any case. Now let's first consider the case. This is the case of J equal to L plus 1. Let's consider this case. For this case, then let's look J equal to L plus half M such summation, right? So that is M L, okay, from minus L to L, M S from just plus from minus half to half, right? In general, but M L plus M S equal to M always. So here and then there's C L S. Okay, that's already half. So now since I already marked this up to half, that's going to be half. Half J M L M S M and L half M L M S. How many terms? So now let's first, since we have two summations, let's consider ms equal to minus half. Then if ms equal to minus half, here is minus half. ml plus minus half equal to m. M is given, so ml must be given. Cannot select arbitrary, right? Because ML plus half minus half equal to M. So ML only equal to, you move to the MS to equal to M minus MS equal to M plus half, right? Because MS is negative. So for this term is CL half, G is L plus half, right? So ML, still keep ML, but this one is minus half ML half ML minus half. The first term. Second one, when MS take half, then ML has only one, right? So even though I say summation, but it's only for this. So ML is M minus MS, which equal to M. Now S is minus half. CL half J ML is half ML half ML half. Only two terms, right? So on the next step, then the other case I just jump this intermediate. The first case, now here the first one is only CL half. Now J is L plus half, right? And then the ML is M plus half minus half M. L half M plus half minus half plus second coefficient M minus half half M L half M minus half. So the remaining job is we are going to find these two coefficients. When we have these two coefficients, then we can write down this geometric space in terms of given L and M value. So in order to this, we are going to apply the recursion measure, relation. Remember, apply the second. We are going to the second recursion relation. You may ask why the second. The second can help us in this case. And let's see the second. Let's just check the minute. Remind the second is J plus minus M, J minus plus M plus 1, J1, J2, M1, M2, Jm is equal to J1 plus minus M1, J1 minus plus M1 plus 1. J1, J2, M1 minus plus 1, M2, Jm minus plus 1 plus second term, J2 plus minus M2, J2 minus plus M2, J2, M1, M2 minus plus 1, Gm minus plus 1. Okay, we are going to use this. This recursion relation can help us to find these two CT coefficients. So we need to spend time one by one. Let's start from this one. We want to find this. You can see here M2 is fixed, right? It's magnetic. So in this case, if M2 is negative, then I use alpha sign. J2 plus negative, that's 0, right? So that means this term will disappear. This one only equal to this one. Second term, M2, the MS is half to is plus, right? So if you use lowercase, this term also disappears. Only one term. That is the way we can reduce the unknown values, right? So that is now why we use upper and lower. I just gave you explanation. So now let's first for the first one, right? For C L half L plus half, and this is M plus half minus half M. We use upper. Upper side. Upper side means upper side of this one, right? So here, the upper side that here because let's summarize here. So here, M2 is minus half, right? And the M1 is M minus M2. In this case, right? I just M2 is in this case MS. M1 in this case ML, right? So that is M plus half, right? And J in this case, J is L plus half, right? That is remember the J1 the J1 is half. Oh sorry, J1 is L. J1 is L, J2 is half. Right? So just remember those numbers and then substitute into this formula so you know it. So now with upper, right? So now let's first right hand side. J is L plus half, right? That's J. Upper side is plus M. Here. And then here, J is L plus half minus M and plus 1, right? This term. I have mine because I take upper side. And then here, J1, J2, so that is L half. M1 is here, M plus half, right? Yes, and the M2 is minus half. And then J is L plus half. Yeah. Right, that is right hand side. Now we go to right hand side. Right hand side, square root. J1 is L, right? So L minus M1. M1 is ML, right? So now I'm going to use, so it is M plus half. I use upper is a plus, right? So I use upper side. J1 plus M, M1, right? So J1 is L plus M1 is M plus half. It's here, right? So that is the first term. And then second one, J1 is L minus, okay, M plus half, plus 1, right? Here. J1 minus M1 plus 1. Then here, now is J1 is L, J2 is half. Now here, that is M1, so M1 is M plus half. And I use upper, so minus 1, right? Here. Minus 1. And then this M2 is still minus half. Then here, J is L plus half, and M minus 1. That is the first term. And then second term, I already said that is 0, but let me write down here. So second term, J2 is half, and plus minus half, because M2 is minus half, right? And then half minus half plus 1. And here, J1 is L, J2 is half, M1 is M plus half, M2 is minus half, minus 1, right? So this cycle is not exist. You know, that is automatically, the coefficient will determine this exists now. So here, then this J is L plus half and M minus 1. So this one, 0 automatically. And now, let's reorganize the right hand side. So right hand side is first L plus M plus half, right? And the second term is L minus M plus 3. Plus 3 and half. M plus plus 3 and half, right? And this called this is L half m plus half minus half L plus half m equal to only the first term. So here this is a square root L plus m plus half. Second, L minus m and plus half, right? Because this minus half is plus half. L minus m plus half. And then here L half and this m plus half minus half L plus half. I think I need this one, right? Oh, this is like this one. Wait a minute, I kept it here. This is this one, right? This term. So m plus half minus m minus half. And this is minus half. Then this is L plus half m minus 1. Now we have some term we can cancel. Right hand side we have L plus m half. Right hand we have this, so these two terms cancel, right? Then we have this is we are going to find, right? That is coefficient here. L half and m is ml is m plus half and minus half, right? This one is this. We are going to find. So let's see. L this one, right? L half m plus half, yes. And minus half L plus half m is equal to, I have this one remaining, I have this one go to the right hand side denominator, right? So numerator is L minus m plus half, and the denominator L minus m and plus 3 half. And the state is L half m minus half minus half L plus half m minus 1. I have this. I'm going to use this relation. Okay. Once we're done here, you say, okay, but we do not know this one. We want to find this, but we do not. We need to go to next one. Right? So how to find this one? That's we are going to see here. Here, I'm going to assign or define. Just let. Let m minus 1 equal to m prime, a new one. In this case, so that here, this one is ml, right? So the ml equal to m minus half. Now, because m minus m prime, so m equal to m prime plus 1, right? So that is m prime plus 1 minus half equal to m prime plus half. So this term, I can rewrite in terms of m prime plus half and minus 1 is equal to L half is fine, but m minus 1 here, m minus half is became m prime plus half, and this m, the m2 is still minus half, right? L plus half, m minus 1 is m prime. So now you can see this one. Only difference is m replaced by m prime, but other things are the same, right? Here, L half m plus half, L half m prime plus half, minus half, and L plus half m prime. So this will be same, right? The only difference. So now this one, I'm going to immediately use this result here. Just replace m by m prime. Do you agree? So here is L minus m prime instead of m plus half and L minus m prime plus 3 half. Now here L half, now m prime minus half and L plus half n prime minus 1, right? Then how about this one? We do the same thing. Let n double prime is n prime minus 1. We do the same thing. So now, then here, n prime minus half is become n double prime plus half. So, I just write one term and then I will use the following. So that is L half n prime minus half L plus half n prime minus what, right? Is become L half n double prime plus half minus half L half plus half n double prime. And that should be equal to L plus or minus n double prime plus half, and the denominator is n minus n double prime plus half. And again, L half, now n double prime minus half, L plus half, n double prime minus half. So you see that we just follow the thing to define this new m, then we can get this, follow this relation. So finally, this is what we are going to find, right? This is what. Finally, this one, the coefficient L half m, it's minus plus, right? M plus half minus half L plus half n is equal to the first one, L minus m plus half, L minus m plus 3 half. Second one is L minus m prime plus half, L minus m prime plus 3 half, until, suppose the nth, L minus m nth plus, okay. Plus half L minus m to the nth times substitute and plus 3 half. So the last one is L half m to the nth minus half and minus half L plus half m n minus 1. Finally, right, so that we have a lot of, just replace this with the new m prime or then double prime, triple prime until to the nth times. Each one the same, just different this one, right? Okay. So when we write down here, say you will see the log of term is cancel each other. So first one, let's see here. M prime, remember? So this term is m prime is m minus 1, right? So that's L minus m. Minus 1 became plus, right? So that is plus 3 over 2. Here, L, I'm going to keep here this one. So you see here, this term cancel, right? And same thing to the other terms. There we follow me. Here. First one is m. Second one is all the same, but the m replaced by m prime. But m prime is, remember, m prime is m minus 1, right? I will define here. So if you replace m prime here, you will see that is nothing but L minus m plus 3 half. So that is numerator, denominator cancel. Similar thing for this one, cancel. So all the others cancel, only the remaining term is this one. Is the last term and the first term. That is very good, right? So now, finally, it's only L minus m plus half L minus m to the nth times. This is not power, right? Just replace by n times, right? 3 half. And state L half m n minus half l plus half m n. Only the last one. Okay. Now, how to determine to which we stop? This like each time we reduce by m by one value, right? M minus 1, m minus 2, m minus 3 until this one. So the minimum value, because we know the m is from j to minus j, right? For given j here, the minimum value is negative j, right? So these values will go to minus j. And in this case, is L plus half, right? Sorry, minus L plus half. This is a j, right? And equal to j minus 1. So that is the limit. The m cannot go further, right? So if this case, okay, then that is one thing here. And second one, from here we can have m to the n times how much it is. You move 1 to the right hand side, right? So that's minus L plus half. Okay, now we are going to substitute here. Replace m to n times by L, right? So now finally, here L minus m plus half, and here L minus, so that is minus L plus half, right? Plus 3 half. That makes sense? Yes. And then the states here have a space and L half. So now m to the n side is minus L plus half. Here I have minus half, that is minus L, right? Minus half. And this is L plus half minus space. Multiply here, L half. So that is minus L plus half minus half. That is this term, right? M to the n times and then minus half. And L plus half. So m to the n step minus 1 is minus j is minus L plus. Okay, now let's finalize. So here L minus m plus half. Denominator L minus L is 2L, and then this is minus half. So that's 1, 2L plus 1. Right? And it stays here L half. So here this one cancelled, minus L minus half, L plus half minus L plus half. This is a coefficient, the first coefficient. That is what we obtain. We use the upper sign of, I erase, right, but hopefully you will remember that. We use the upper sign of the recursion relation, second recursion relation. We obtain the first coefficient for j equal to L plus half. Now, the second coefficient, we do the same thing, but we use lower part. Oh, I have to finish. So here, let's just write it here. Remember this? You may say, okay, this coefficient, remember this? This is j1, j2, minus j1, minus j2, j maximum, minus j maximum, right? This coefficient is one of limit equal to 1, right? So this one equal to 1, so now you immediately got this L minus m plus half 2L plus 1. That is the first coefficient. Okay, now second, we are going to use lower part. Do the similar things, so I will speed up a little bit to save time. So we spend more time. Okay, so for second, remember that is L half, L plus half, m minus half, right, and half. Yeah. This is second, right? The second coefficient, we use lower sign of this recursion. So I immediately use, and here, just remind here that is M2 is half, here, right, positive. And M1 is ML, which is M minus half. Okay, so here, G again is L plus half, right? Others are same thing, so I think that's enough. All right, so now here, we substitute the equation, let's just write down here. If you remember, so that's L plus half, G now is minus M, lower part. And this is L is plus half G plus M plus 1. So that is the lower part. Okay. Yes. Lower part is minus this way. And the coefficient here, L half, and M is, L is M minus half, and M2 is half. So here G is L plus half, and then like this way. That is the left-hand side of this lower side of this second recursion method. And again here, G1 is L. L minus, so at, okay, I just write down here, and the sign already consider. Minus M, ML, which is minus M, and minus half, and plus half. L plus M minus half plus 1. And this states is M minus half plus 1, that is no half. And this M2 is still half, L plus half. M plus 1. This is second term is 0, but let me write down here. Second term half minus half, that's 0, and half plus 1. So this is since this will half M minus half plus 1, so that stays like this. And 0 plus half M plus 1. So this stays 0. Then we have these two terms organized. So now just quickly write down here. So this coefficient, second coefficient, this one is here. 0 plus half M equal to square root. You will see this term, and there some term cancels, so now I'll give you, which is L plus M plus half, and L plus M plus 3 half. Previous one we use upper sign, which is L M minus M, right? Just L plus M plus L half M plus half L plus half M plus 1. So that we are going to use this relation and go to the next one. So now we are going to let M prime is M plus 1. So we're going to find this, right? And you'll find this one is actually same thing. So if I assign M prime to M plus 1, then here, then M plus half equal to M prime. M equal to M prime minus 1, right? So minus half. Then this one, then, so this term is L half M plus half L plus half M plus 1 equal to L half n prime minus half, half, L plus half, n prime. And this same thing like this. So I will just write out the final, so I'm going to come down to here. I need to write one more. I think finally, it's a middle one. Finally, the coefficient L half m minus half half L plus half m is equal to the first term is that one, right? L plus m plus half L plus m plus 3 half. Second term, L plus m prime plus half L plus m prime plus 3 half. And go to final. Go to final one, L plus m to the nth term. Replace m by nth term. And the final L half, which is this one, right? Nth term plus half, half L plus half, and nth term plus 1. This is erasing. The first one is lowering, right? So for this case, again, this one has an upper limit. Since this is G, right? G is equal to G maximum. And here, n to n stamp plus 1 is equal to G maximum, right? Which is equal to L plus half. So with this, then m to the n stamp is L, moves 1 to the right hand side, is L minus half, right? And now we can come down here. You will see this term cancel this term, because m prime is equal to m minus, m plus m plus 1, right? So then m plus 1 is L plus m plus 3 half. That is this one cancel. So the remaining term all cancel. Then the final we have L plus m plus half, L plus m to the nth times plus 3 half, and L plus m nth times plus half, half, L plus half, m to the nth times plus 1. Now we can remove n m to the nth time by that L minus half. So that's L plus m plus half, L plus L minus half plus 3 and half. And this is L half. So L minus that is L, right? M to the nth times is L minus half, and plus half, that is L. Finally. Then again, in this case, this one, this is a G max. This is also G max, right? So this coefficient is 1. Remember this? So finally, equal to L plus m plus half to L plus 1, right? Here, to L plus 1. And this is equal to 1. Now we can summarize, since we have obtained these two coefficients for L equal to, for G equal to L plus 1. Let me just sum them together. Finally, here for the G equal to L plus half and M for any M, we have the result is L minus m plus half to L plus 1. In this case, is correspond to the space is L half m plus half minus half. This space, right? The second one is just use here, right? In this one. L plus M plus half. 2M plus 1. L half. M minus half. Half. That's all. So these are two coefficients we obtain. So in this case, we apply the recursion method, then we can very easily obtain the any. So in this case, once J given is L plus half, then the allowed M we can change from L plus half, minus 1, minus 2 until minus L half, L plus half. So all states is just change M. So we have this group, right? That is for this. Now second case for J equal to L minus half. We do the same thing. So let's first extend this how many coefficients? So L minus half M extension, right, by M L M S and C L S L minus half M L M S M L and just S already is half, right? So half M L M S, right? That is where extend, and we know the S can only have a plus minus. So when MS is minus, this one is plus, right? So we have the first one is C L half L minus half M is M plus half minus half L half M plus half minus half. Second one, when the MS half, then the ML be M minus half, right? So that's M minus this one's to similar. Only difference is L is minus G is M minus half. Okay, so when we need to do this again, right, using the second recursion. And I will not do the details, follow the same thing. I just give you a result for these two. One is use upper sign, another use lower sign. Similar. Now,
Dr. Yu,
yes.
can I ask you how you're canceling out the parts of the square root again?
Yeah, okay. This term and this term, M prime is, I think I used the M
A minus 1.
is minus, right?
M plus
M is plus, right? M plus 1, so then became L plus M plus 1 plus half is 3 half. We cancel.
Oh,
Same thing for others. Until finally, only the numerator here is, right? The others will cancel. This one cancel with the previous one. Good. So now, same thing. So now let's first we got this one, right? So for C L half, L minus half, M plus half, minus half, M, we use upper. So we have, so similar, right? So just you can do yourself easily. So similarly, the result. Okay, almost the result before that last time. Okay, here. So this one is L half M plus half minus half and below minus half. Yeah, right. That is this coefficient. That's equal to square root L plus M plus half L plus M minus half and L plus M prime plus half L minus M prime plus half and minus half. So plus M prime minus half until last one. Q, last term is L plus n to the nth term plus half L plus n nth term minus half. And the state is L half n nth term minus half. And this is minus half L minus half n nth term minus half. Minus 1. And again, with this one, we go down and Q go to the negative L minus half, right? So the n minus 1 equal to negative J value, right? So in this J is L minus half. It's minus L plus half. So that is the reach to this, right? Then this the n inside is minus L plus 3 half. Okay, then if we substitute here, you will see finally the coefficient is L half n plus half minus half L minus half n is equal to. We just substitute as the final equal to L L plus n plus half. And states L half minus L plus 1 minus half L minus half minus L plus half. But this one is not two limits, so we are going to say this is A. We are going to determine this. That's different from the first one. First one, just the J equal to J maximum. So we can use the coefficient for two limits. But here J is not J maximum, it's J minimum, right? So here. So we are going to assume this is A, that is A multiply this. Then we are going to determine A. Similarly, for this lower part, do the same thing. The second topic, right? This is for this one. Second L half L minus half. Then here M is M minus half M. We use lower side. Then I give you final because even those are similar, so I will. L, this is this coefficient, right? L half n minus half L minus half n equal to L minus m plus half. And here this is L half. ML is L minus 1 and half L minus half L minus half. Here we do not know, so we say the B. Okay, so this case, right? So here I'm going to replace this one and these two coefficients by A square root L plus n plus half and this B square root L minus n plus half. But we have to get A and B. In this case, we do not know that coefficient, how to do this. We can apply the orthonormal. So, for A and B, apply here. Right? One is normalized with the same states. Another is orthogonal with other states, right? So now let's do this. This state is this one, right? So L minus half m L minus half, and the same state is equal to 1. Another is L plus half m L minus half m equal to 0. We have two unknown variables, two equations enough, right? So now for this one. Let's look here. Because these are orthogonal, right? So the states, the inner product, only this one is bra is equal to 1. With this one is 0, right? Because they are orthogonal. And second, so that means very easily is a square. This square is L plus m plus half, right? Second term b square and L minus m plus half. This is equal to 1. That makes sense? This is a coefficient, right? So when you, because these two states are orthogonal, already. So when we do this, actually is two states, and this bra multiplied same state is this one is 1, and other states here. So we have this. And for orthogonal is L plus half m, L minus half m. Remember we have the first one, L plus, we have 10, I just erased, so let's just remember. L plus, we have L plus is square root, L plus and minus L minus m plus half 2L plus 1, right? Remember this? Okay. And that is correspond to this state, right? So only multiply this one is non-zero. L plus m plus half. That is the bra of this one. The coefficient corresponds to the same states. That is one. And plus the second one is L. Second one is L plus m plus half 2L plus 1. And multiply this. So multiply b square root L minus m plus half. This equal to 0. Okay, so now you can see here they are same, right? So the L minus m half multiply L plus m half. Here L plus m plus half L minus half. So this cancel, right? That means A plus B equal to 0. So A is B. Then we substitute into here. So then here we have A square L plus m plus half plus minus A square L minus m plus half equal to 1. And here you see this m cancel, right? Then here the L plus half, the 2L plus 1. L, this is 1, right? So 2L plus 1 in square equal to 1. A is 2L plus 1. And finally, I come down to here. Equal to, remember here, I write down this one. 2 plus 1. And minus. That's fine. So those techniques, I want you to familiar with those. Homework, you may also use that. Similar like the same idea, also same skill on this. Okay, so I thought I can finish this week, chapter 7, hopefully, yes. Then next week we can start with chapter 8. All right, so this is some details, but I think this is good for the detail. Then you learn how to deal with those. I think textbook gets some of them, and not all of them, but of course I also didn't give you the details. I want you to do yourself. Then we are going to summarize these two states. So we have this one and plus minus, this plus and minus. This now we are going to apply a case. Suppose we have applied this hydrogen atom in this, suppose we have Hamiltonian is H naught plus carbon. H naught is the central force, like the hydrogen atom of chapter 6. Central potential field. And this is a coupling. Now we call coupling. So now we add this coupling term. That is more whole picture of this hydrogen atom or electron. Previously we ignored spin, right? Now we include spin, so we have this additional term, and you will see the energy split due to this action or coupling. So we're going to do one example on Wednesday for this, and see how the energy depends on different quantum number. For this case, we know it's highly degenerate, only depend on quantum number n, right? But then here, you will see for giving LS with an additional term. So that term will give us the energy actually depend on, or reduce the symmetry, reduce the degeneracy, right? Or left the degeneracy. Okay. Try to work on homework, and now that is also a lot of work you need to do. Okay, nice, you can start now. Start from now. First two questions or first three, you are okay, I think. You already finished this, so I think you can know. The last one on Wednesday, you have a question? The last one on Wednesday, that is the three angular momenta addition. So how to deal with the three angular momenta, we're going to discuss on Wednesday. Yes. Discussion sheet, did it sign?
Yes.
Okay.
Can I take a picture of that real quick?
Yeah.
Okay, thank you.
Let's see, I have PLC from 12 to 2, so there's usually like 5 people waiting for me when I walk into the field series
Oh,
at all times.
they love Jacob.
Huh?
Said, do they love you?
I guess. I'm like, hello, Ali, hello, Brett, hello, Spencer.
Jam.
You ready to go?
Oh, shit. Get him. Get him. Get him. Jump.